How does the soldier of today become the soldier of tomorrow?
You see technologies now progressing to the point where it makes sense to put an exoskeleton on the battlefield.
Imagine if we could replace all the small arms projectiles with one. If the soldier has a rifle, he has the same capability as an M1 Abrams tank.
Cloaking is essentially invisibility. I think you can think of many possibilities where you're out in the battlefield and you'd like to not be seen.
Making warfighters and their gear lighter, stronger, and safer with more firepower. Ensuring America's future soldier is a decisive weapon.
There are so many tasks within the Army that we ask soldiers to do every day that are heavy lift tasks, that are sustainment, that are long-term marches. And if we can provide something that makes what they do every day easier or allow them to do it for a longer period of time without physically getting exhausted, it helps him on the battlefield. Whether it's advanced sensors, whether it's running faster, to be able to carry a heavier load for a longer distance, a device that knows you, that can learn you, and if it needed to, it knows how you walk, so maybe it takes you back. There's so much potential, I think, when you provide a frame like that or some type of device for personal augmentation.
One of the issues we've been looking at to distribute the load effectively or to help the soldiers carry load is the idea of the wearable robots or the exoskeletons. We looked at the full body exoskeleton as well as just strictly a lower body, where the lower body is just carrying the backpack load and a full body has the ability to either do that or carry manual load carriage in the arms. At this point, the engineering has demonstrated that it can work. So the next question is, as physiologists and biomechanists come together with engineers, the question is how well will it work? If soldiers are expected to carry 120 pounds and walk at 3 miles an hour in the field, we're certainly going to evaluate it to that degree in the lab. And one of the things that we've gotten smarter with over the years is that you can't just take a novel piece of equipment and expect someone to wear it. So as we get smarter in our research protocols, we've been building in more and more learning time, familiarization. It's an interesting feedback that we get. Some of the soldiers felt like they were more used to carrying the backpack by itself without the device because that's what they're used to, whereas other volunteers felt like they'd rather feel the effects of the device than rather have to feel the effects of the load on their shoulders. We've tested 2 prior versions, and each time we're seeing incremental improvements in how well it works. Our long-range research plan is to be able to address things in a very isolated environment here in the lab, and then to grow that research out and start getting into the field more.
You have to enhance the soldier's strength to enable him or her to carry what they need to carry, giving him a better fit to the equipment that we have and actually designing and building equipment around his needs. The exoskeleton is an option that we have. It can provide considerable strength to carry things. One of the disadvantages is cost. And the question is the maintenance. The question is who would be wearing the exoskeleton, on what missions.